Very good morning, students. So far we have completed up to conductors and insulators. In the last session we have completed up to conductors and insulators. Today in this chapter we are going to discuss about effects of electric current. Effects of electric current. You performed many experiments with the electricity in the standard 6th and learnt quite a few interesting facts. Right, students? For example, you saw that a bulb can be made to light up by making electricity to flow through it. When we allow electricity to flow through the bulb light up. Right, students? The light of the bulb is thus one of the effects of electricity. Glowing of light is one of the effects of electricity. There are several other important effects of electricity. Is there? We shall study some of these effects in this chapter. So there are three main effects of electricity as heating effect, magnetic effect, chemical effect. In this chapter we are going to discuss about heating effect, magnetic effect and chemical effect. The first one is heating effect. When an electric current passes through a wire, the electrical energy is converted into heat. We can notice it. Whatever the electrical appliances it may be, when you consider the television, after you watch the TV by 1 hour, after watching 1 hour, when you touch the TV, we feel some heat. So what happens? The electric current, some of the energy is converted into heat. In heating appliances, the heating element is made up of materials with high melting point. An example of such a material is nichrome. Nichrome is the alloy of nickel, iron and chromium. Nickel is the alloy of nickel, iron, chromium. Alloy in sense, you know well, two or more metals together will make a alloy. We can make a alloy. Mixture of two or more metals only we are calling it is alloy. The heating effect of electric current has many practical applications. The electric bulb, geyser, iron box, immersible water heater are based on this effect. These appliances have heating coils of high resistance. Generation of heat due to electric current is known as heating effect of electricity. So what is the heating effect, students? Heating effect of electric current is nothing but generation of heat due to electric current is known as the heating effect of electricity. So we have many appliances which we are having in our house that we can see it in the picture itself, students. These and all example for the heating effect of electric current. Have you understood, student? These appliances which produces heat. So heating effect of electric current. What are the factors will be affected? Factors affecting heating effect of current. The first factor is electric current. Second factor is resistance. Third factor is time. Have you understood, students? Some of the factors affecting the amount of heat produced are as follows. What are the things? The strength of electric current, or else simply we can consider as electric current. Next one is resistance. Third one is time. Have you understood, students? Based on this, the first one is electric fuse. Electric fuse is a safety device. We can notice it, students, this type of electric fuse in our house. Electric fuse is a safety device which is used in household wiring and in many appliances. Electric fuse has a body made of ceramic and 2 points for connecting the fuse. 2 points for connecting the fuse wire. The fuse wire melts whenever there is a overload of the current in the wire. This breaks the circuit and helps in preventing damage to costly appliances and to the wiring. In electrical devices, A glass fuse is often used. This is a small glass tube in which lies the fuse wire. So nowadays we are having small fuse also is available in our house, students. We can notice it. The next one is MCP. What is it, MCP? MCP stands for a miniature circuit breaker. Miniature circuit breaker. MCP have been replacing electric fuse from wirings at most of the places. We can notice it in our house, students. AC switch and all will be like this only. This is the miniature circuit breaker. Miniature circuit breaker. The electric fuse has a big practical problem. Whenever the wire fuses, one needs to replace the wire to resume electric supply. Yes, students. More often than not, this proves to be a task. Miniature circuit breakers break the circuit automatically. One just needs to switch it on to resume the electric supply. Many models of MCPs have a built-in mechanism by which the electric supply is automatically resumed. Next one is a magnetic effect of electricity. What is it, students? Magnetic effect of electricity or else magnetism. In 1819, Hans Christian Ørsted discovered the electricity that has a magnetic effect. With the help of the experiment, he proved that current carrying conductor produces magnetic field. Have you understood, students? Magnetic effect of electricity is nothing but current carrying conductor produces magnetic field. Current carrying conductor produces magnetic field, which was discovered by Hans Christian Ørsted. And the next one is chemical effects of electric current. What is it, students? Chemical effects of electric current. So we have completed a heating effect and magnetic effect, and now is chemical effects of electricity. Chemical reactions happens when electricity passes through various conducting liquids. Have you understood, students? Chemical reactions happens when electricity passes through various conducting liquids. This is known as chemical effects of electricity. And the next one is applications of the magnetic effect of current. We have so many applications. Magnetic effect of electric current has been used in making powerful electromagnets. Electromagnets are also used to remove splinters of steel or iron in hospitals dealing with eye injuries. We have so many applications, students. So the picture shows the electromagnets and the uses also here we have. Electromagnets are used in many appliances that we use in our day-to-day life, namely electric bell, grains and telephone. Let us know how the magnetic effect of electric current is applied in telephones. In telephones, a changing magnetic effect causes a thin sheet of metal diaphragm to vibrate. The diaphragm is made up of a metal that can be attracted to magnets. The diaphragm is attached to a spring that is fixed to the earpiece. When a current flows through the wires, the soft iron bar becomes an electromagnet. The diaphragm becomes attracted to the electromagnet. Look at the picture where we have the diaphragm, students. So here we have a diaphragm. As the person on the other end of the line speaks, his voice causes the current in the circuit to change. This causes the diaphragm in the earpiece to vibrate. in producing sound. Have you understood, students? The diaphragm is nothing but which is the thin sheet of metal which is used to vibrate. The diaphragm is attached to a spring that is fixed to the earpiece. When a current flows through the wire, the soft iron bar becomes an electromagnet. I told you already. And the next one is, so let me have an interesting fact about Thomas Alva Edison. You know well, he has invented so many electrical appliances. We know well. Thomas Alva Edison was an American scientist and industrialist. He invented many instruments like electric bulb, electric motor, gramophone and kinetoscope. He was known as for taking the world of darkness to brightness. Right, students? He is the only person. He took us to the brightness world, crossing all the obstacles in our life. He was known as for taking the world of darkness to brightness, crossing all the obstacles in life. Have you understood, students? So, we will discuss about the Thomas Alva Edison. When he was a child, his hearing capacity was reduced. One day, his teacher scolded him, and that day he dropped out of the school. After leaving the school, his mother, who was a teacher, taught lessons at home for 3 years. Since the age of 7, Edison was interested towards domestic electrical devices. At the age of 9, he read the book Natural and Experimental Philosophy, written by Richard Parker. At the age of 21, he read deeply Michael Faraday's experimental researches in electricity. Edison worked as a telegraph operator in railway station. He was the dynamic telegraph operator. His first invention was electrical telegraph and its related instruments he discovered. He invented an advanced instrument gramophone. The picture shows the gramophone, students. He used a platinum wire coil in a vacuum glass and discovered the first electric bulb in 1879. Thomas Alva Edison invented a commercially viable electric bulb. This was exhibited in 1897, only I told you. By using mechanical power in a battery, electric power was generated by providing the voltage. Edison proved that voltage is given in the ends of the battery. The same was transferred into an electric motor which provided a mechanical energy. Have you understood about Edison, students? So which is there in the book. You yourself you can wonder about Thomas Alva Edison, and you may impressed by Thomas Alva Edison. I hope you all understood, students. So the lesson gets over. Stay safe, students.